The idea is you use a laser to transmit electrical power through the air, without wires, to a device at the other end that uses that power. The way it relates to the space elevator is the idea that you wouldn't pull a cable up and down like you might do in a pulley on an elevator, because then you'd be moving twice the weight of the cable. So the idea is it would be self-propelled and it would just climb the cable. So knowing that we didn't have a cable that could go out that distance, we could still demonstrate that part of it, which is the power transmission from the ground. And of course, the reason you want to transmit the power is you don't want to have to carry all of that on board the object that's trying to climb. So an allied organization, an outside organization we worked with, really set this up. And they started with just a crane and a 100-foot cable, and people came out, and originally they were mainly using sunlight and mirrors and solar panels to drive their little robots up these cables. And then it progressed to 100 meters, and then the last version that we did, and no one won those early ones, but they did pretty well. And so the goal kept getting raised, and the prize got raised. So there was a $2 million pot the last year that we did this, and a 1-kilometer cable. And the biggest problem, of course, is how do you even set this up? You can't get a crane. So they considered a balloon, but there were a lot of problems with that. Ended up using a helicopter. And what made this interesting is no one had ever done anything like this. There had been helicopters connected to the ground with cables, but not 1,000 meters up. And so that's what we did. We went out to the Dryden Flight Research Center at Edwards Air Force Base, a big dry lake bed where they do all kinds of experimental aircraft testing. Is where the shuttle originally landed, and flew. It took several attempts. We broke 2 cables in the early testing. We got ultimately a very good helicopter pilot, and he practiced a little bit, and raised this cable up, and it was somewhat like a space elevator, because you could see the cable in front of you and go up for a little ways, and then it disappeared. Occasionally you get a glint of it in the sun, but you couldn't see the top of it, and you could barely see the helicopter. If you didn't know it was there, you wouldn't have noticed it. You couldn't hear the helicopter. So it was just a cable going up into the sky. It was quite a cool thing to see. And then these teams had, this point they had progressed from sunlight and mirrors to laser, fairly high-power laser systems. And then they had their beaming trailers on the ground, and they would, we raised it up 100 feet to the starting point, and then they beamed their laser beam on the panels on the bottom of this robot, and they climbed. And we had 3 teams trying. 2 of them were fairly successful in climbing quite a bit. One got very close. The other one just completely nailed the challenge, at least at the first level, which was a speed of at least 2 meters per second. So they won $900,000. They climbed all the way to the top at an average speed of actually about 4 meters per second. If they had reached 5, they would have won the full $2 million. And they got close to that too. They only had a little glitch that prevented them on their last attempt from making that. It was quite a thing to see. There's some wonderful videos on the internet of that activity, set to music, which is quite interesting. So it was a great thing. We weren't really able to repeat it. This program is, we only fund the prize money. The challenge activities have all been run by nonprofit organizations in partnership with us. So it was very difficult to put this together again. The helicopter operations, for one thing, were expensive. And he would go up for hold position for 45 minutes, and the cable barely moved. Wow. It was the most amazing thing. And he was up there with no references to look at. He used the GPS and to hold his position, and a guy on the ground kind of giving him directions. But to do it again, just it was difficult to pull off. I think it was a one-time kind of thing, and so that second part of the prize was never won. And the team that won, they've really gone on to do lots of other things. One thing, they've demonstrated a little scale model helicopter that they run, for hours, off the ground, just beaming the power to it, and they could do it forever. They just got tired, but the system would just run forever without using any other power. So they have lots of ideas for things they'll do with this power beaming technology. The other thing we find, from NASA's point of view, you could have a rover in a dark crater, for example, going around, and you just had to send the power to it this way from a power station on the rim. You could power things from the orbit of the moon down to the surface without having to have the power supply there. Probably on Mars as well, and then beaming power from one spacecraft to another in orbit. You could do a lot of things with that. So that's another whole area that it has all kinds of potential, and we hope through things like these prize challenges we open people's eyes to what is possible. Doing things that maybe nobody bothered to do. It sounded too hard. It sounded too crazy. If we have a chance to do them, sometimes you find out that it's more realistic than anybody thought, and that's really what we hope to accomplish with these things.
I guess another aspect of the debate that I've only seen a little bit of, but I'm actually really curious about, is where you anchor it to the Earth. And sort of the two options are: you anchor it to the actual crust of the Earth, or you put it on some kind of floating barge boat situation.
Yeah.
What of that debate have you seen? I mean, what's the sort of sides there?
Yeah, the problem of anchoring the space elevator is one of those engineering issues that once you have a material that might work, then you really have to get down to how you do that. But, you want to be on the equator in order to take advantage of the position in orbit above that. So you look at a globe, and there's a lot of water, in the ocean might be the most reasonable place to do it, because you probably want to be in a place that's somewhat remote in case things go wrong. So a platform in the ocean seems like a good idea. You could be out kind of in international water, and I don't know if you may want to have some ability to move the base around a little bit and have some flexibility so you can absorb changes. In fact, that's what we did even for our 1 kilometer cable. We had 3 smaller cables connected in a tripod on the ground, and at the end of each of the short cables there was a heavy chain, and that absorbed any of the motion of the helicopter and the wind affecting the cable. But in the end, the pilot got so good that he could watch, and there would be one link of the chain moving a little bit. That was the stability, even in pretty strong winds. That kind of gives me the confidence that those kinds of technical problems that are not easy will be solved one way or another. Some way to absorb, the motions that would probably be there in the cable, at one end. The other end would be pretty stable because it's sort of following the laws of orbital dynamics. It's going to be very predictable. The other end on the Earth is much less predictable. So I think a platform at the equator in the ocean probably makes the most sense as a base of it.
Mm-hmm. And so once you get that sort of challenge done, I guess I'm sort of curious about what exactly the sort of ideal materials you'd be moving up and down the space elevator. I mean, once you actually get it constructed, what are you actually putting up there? And what's the goal?
Yeah, the goal is to replace the normal way of taking using rockets to take things up and down with this elevator that would take up, first of all, people. Now, it would take you days to get there. It's more like an ocean cruise than a trip in a rocket. But there would be no unusual accelerations. It would be, you could sit in a chair, and you could stand up, you could walk around. It would be like you were on a cruise ship or something, or even on, maybe on an airliner. But so people up and down, and again, the return would not be the fiery, dramatic reentry that you normally have, but you just ride back down again like you went up. A little bit like riding, the first time I went on a hot air balloon, I said this is like going up in an elevator. It's amazingly calm, and coming down can vary depending on what happens, but this should be a very predictable descent on the elevator. And then everything else we need, materials and equipment, which would not have to be now designed to withstand, the forces of acceleration and a rocket launch. You just take ordinary things and put them in there and take them up, and take them off when you get at the probably somewhere along the way you would, before you got to the counterweight, you would get off, and and of course most of what we launch into space now is, if we're going beyond Earth, is propellant for the rockets to go beyond. I'm hoping other research we're doing will reduce that, and we'll begin using much more efficient rocket engines that won't require huge amounts of propellant. But at least the way we look at things now, that's a big part of what we have to take up. If we want to go anywhere else, we need the fuel to take us there, and then food and things. What might end up happening, and you can imagine at this future point, perhaps a lot of what we'd be using it for is to bring things down. Things that came from resources that we were getting from asteroids or from the moon, being brought back to be used on Earth. Industries that might move to space where they would be less, have less impact on our environment. That begins to make sense if you have a way of moving them back, in a reasonable way at a reasonable cost. And again, that's something the elevator would enable. So it could almost sort of turn the whole thing upside down, where most of the traffic might be coming the other way. If we're now using space as a place to get resources instead of from the Earth, and using space as the real base for our industrial activity. And the idea is you use a laser to transmit electrical power through the air, without wires, to a device at the other end that uses that power. The way it relates to the space elevator is the idea that you wouldn't pull a cable up and down like you might do in a pulley on an elevator, because then you'd be moving twice the weight. And versus, how do you even set this up? You can't get a crane. So they considered a balloon, but there were a lot of problems with that. Ended up using a helicopter. And what made this interesting is no one had ever done anything like this. There have been helicopters connected to the ground with cables, but not 1,000 meters up. And an allied organization, an outside organization who worked with, really set this up. And they started with just a crane and a 100-foot cable, and people came out, and originally they were mainly using sunlight and mirrors and solar panels to drive their little robots up these cables, and then of the cable. So the idea is it would be self-propelled, and it would just climb the cable. So knowing that we didn't have a cable that could go out that distance, we could still demonstrate that part of it, which is the power transmission from the ground. And of course, the reason you want to transmit the power is you don't want to have to carry all of that on board the object that's trying to climb. So it progressed to 100 meters, and then the last version that we did, and no one won those early ones, but they did pretty well. And so the goal kept getting raised, and the prize got raised. So there was a $2 million pot the last year that we did this, and a 1-kilometer cable. And the biggest problem, of course,